Hey everybody, Chris van der Kerk here at Blue Rhino Safaris. I had a question recently about the differences between gel and AGM and spiral and lithium, and what's the difference between these batteries. The first battery we're going to look at is this battery. This is lead acid technology. Lead acid technology, on the battery itself, it is saying deep cycle, rechargeable, AGM plus gel, VRLA, solar energy. So if you didn't think you can get all the names into one, there's a battery that is all of these batteries. And what is the difference? Well, I'll tell you that a little bit later. This is the old technology, this is lead acid. What I'm using at the moment, what I'm suggesting people use is this. This is a lithium iron phosphate battery. New technology, much better than the old technology, more energy dense, and for camping it is ideal because we can abuse it without it complaining too much. So one of the ways to demonstrate this is to say, who of you think you can use this battery upside down? Would you do it with a car battery? Would you flip a battery upside down and run something off it? Or is it too dangerous? I don't know. Let's try it with this one. To avoid any sparks and trouble, just a little bit of insulation. I'm going to use this battery as a base. Then I'm flipping this one over. They are much lighter, so easier to use. Then I'm going to use my trusting camp light. And there you go. Upside down battery. Looks like a car battery. It's a bit scary. No explosions. Nothing happening yet. Light is working. So this is cool. Yeah. To tell you how this works, you need a few things. First, you need your, let's look a little bit more intelligent glasses, because we're going to have to work on a computer. And I'm going to have to show you a little bit of the chemistry behind this. So I'm going to dig into the details of the lead acid battery versus lithium battery. What's the difference? Why is there a difference? Why does the one work better than the other one? All right, so let's have a look at this whole lead acid battery thing. It's not going to take too long, but it is very interesting to actually just go through it. And the history of it is that a lead acid battery was developed as a rechargeable battery. If you've been to school and you remember your science lessons and you took a lemon and you put a copper plate and a zinc plate and you connected the two to a voltmeter or a light, you would see there's power created. There's an acid and there's two different metals. And that system is not rechargeable. It is a once of use. Once you're done, it's finished. But in 1859, a French scientist said, well, looking at where we're going, we can store energy in a rechargeable battery if we use a certain chemistry. So the first important thing about lead acid batteries is that they are rechargeable. That was the whole point of the development. Gaston Planté was the guy who developed it, and it was specifically looked at the use on motors and things that could use electricity. Then in later life, when cell phone towers and solar and all kinds of other things came around, the technology had to change because now companies wanted to use batteries for storage and not to turn a motor, like a cranking motor. The technology, lead acid technology, gives you a very high cranking ability. So it has a very explosive power, but storage is a bit dodgy. And when they needed to start storing electricity, the demand was such that we don't just want a bucket of sulfuric acid with lead in it, and if it sloshes around, we're going to corrode everything. Let's make it a little bit more intelligent in the case of let's seal it. Let's make sure that none of the sulfuric acid gets out. But if you seal it, then in part of the chemical process means that gas has to vent. So it releases a gas, and that gas creates pressure, and then this thing is going to explode. So if you ever see the limitations of a lead acid battery, if you put it in a steel case, the manufacturers will say you're not allowed to do that. It has to have space because the battery moves. It flexes based on the release of gases inside of this battery. But to release some of the gas, you need something, and we call it a valve. And that's where the valve regulated lead acid battery comes from, VRLA. It's a sealed battery. So if you see sealed, it is always a valve regulated battery. If it's not sealed, it means it's open to air, and that means if you turn it upside down, then acid will just run out. So if it is sealed, it is valve regulated, VRLA. And in this VRLA class, we find many different types of batteries. You get the gel battery. So if I take my sulfuric acid in the battery and I make it into a gel, and I now swivel the battery around, this gel will not run out, and therefore it is more secure to use in more orientations. And that is one way of doing it. Another way of doing it is to make the gel a putty, and then it will be even more stable. But now you might start realizing that now you have a acid on a plate, and you're now going to start limiting the contact of the acid on the plate. The other one that they would use is amalgamated glass mat, AGM. And that means that the acid is still a very liquid acid, but they put it in a form of it like a sponge. Between the two plates, there's a bit of a sponge, and that has your acid in it. So if I swivel the battery around, then the acid remains in the sponge. It's not just sloshing all over the place. And that was the whole point of gel and AGM and all of these batteries, was to get away from the fact that you just have a bucket with sulfuric acid that's traveling around Africa having a bit of fun. So it's a lot safer to go for the other styles of batteries. The downside to this is that if I look at my chemical process, and we'll have a look at it now, then in a completely discharged state, you have a very weak sulfuric acid solution in the middle, and as you charge it up, you start changing the concentration. Now, a highly concentrated sulfuric acid weighs different from a discharged battery. That's why in the old batteries, in the old car batteries, you remember you could get that glass tube and you can suck up some of the sulfuric acid, and then you can see how much charge there is in the battery, because the weight of the sulfuric acid changes. Now, as it changes, it goes from a weak sulfuric acid with a very low gravity to a very dense gravity and a very concentrated sulfuric acid. And if it sits somewhere in the middle, then it creates what in diving terms would be called a thermocline, a line, a divide between the watery part and the concentrated part. And that means that you now get oxidation in the watery part and sulfation on the concentrated part. And this is where batteries sulfonate and all kinds of weird things happen, is when this liquid is sitting there and creating these zones. But if it's a liquid battery, then the natural movement of the liquid will mean that the water gets stirred inside. So that's why sometimes you see on a battery charger it says recondition. You press it and you put high voltage through, and suddenly it mixes all this water and sulfuric acid, just to make sure that you don't get those zones. But if you have a gel or a glass mat or something that prevents this liquid from stirring, you're going to end up with something that is not so great, because it has created these two zones. And that's why the manufacturers of these batteries will be very specific how you charge them and how you discharge them, so that they can prevent the damage that you would naturally get from these two zones that appears inside a battery. But let's look at the chemistry a little bit. So in a discharge state, the positive and the negative plate in a lead acid battery becomes lead sulfate, PbSO4. Both sides pretty much the same thing, and the electrolyte itself loses its density and it becomes very watery. And that's why a lead acid battery can freeze in very low temperatures when it's discharged, because it's very watery. All this, the S's and the O's of sulfuric acid, H2SO4, all of the S's and the O's becomes absorbed into the plates. And what's left is just the water, which forms the basis of the chemical process. And if it's just water, it can freeze. And then if you take your density meter with the tube, you'll see that it's very watery. There's no charge in this battery. Then you apply your charging current to it, and suddenly you create a chemical action which drives off the O's and the S's from the plates. And the one plate turns into lead, just a Pb, and the other one into lead oxide, PbO2. And the concentration of all the O's and the S's sits in the liquid now. And that is where your charge in the battery sits, is in the liquid, not in the plates. It sits in the liquid. So you've now moved the O's and S's from the plates into the liquid, and it sits there fully charged. If you apply a light or something to it, then the O's and S's from the sulfuric acid, which is now highly concentrated, fully charged, ready to bang. When you apply a light, the O's and S's will start flowing back to the lead, and the sulfuric acid will become water again. And that is the chemical process of a lead acid battery. It's exactly that. You are constantly moving the O's and the S's between the lead plates and the sulfuric acid. And that is how a lead acid battery works. So here's a picture of a typical, this is a motorcycle starter battery, it's a 12 volt battery, lead acid, stock standard, straightforward, nothing funny to it. So how do you get to 12 volt? First of all, each cell is a 2 volt cell. If you take two lead plates, you put them next to each other, you put sulfuric acid inside, apply a charge, take the charge off, measure with a voltmeter, you get 2 volts. That's the 2 volt, that's the chemistry, that's what it's going to give you. How do you get to 12? You times it by 6. So you create 6 cells in a battery, and those 6 cells each gives 2 volts, and each 2 volts in series will give you 12. So if you look at this, you'll see there is a one electrode on the one side, and it's connected to every second plate. And here is the other electrode, and that's connected to every other second plate. And they sit like a mesh inside each other. If they touch, you have a short, and then suddenly you have a dead cell. If they don't touch and they stay apart, well, then you add acid and you have a battery. So this negative or positive is connected to the negative or positive on the next one. It's in series. This is connected to the next one. It's in series, and there you have a 12 volt battery. Straightforward, nothing funny. If I want to take these plates and spiral them, then I have a spiral battery. Still the same technology, just a different layout of the battery itself. If I take this sulfuric acid, and between the plates there you can see I put a fiberglass mat, and then I put the sulfuric acid in, then I have a AGM, amalgamated glass mat. If I take the sulfuric acid and I make it a gel, then I have a gel battery. If I take it and I make it a putty, then I have some dry cell or whatever else they would call it. But it's the same thing. Lead plates, sulfuric acid, and there you go. So this is just normal lead acid technology. Doesn't matter what you call it. It's just lead acid. So just looking at lithium battery, generally the design of a lithium battery is that the negative electrode of a normal lithium ion cell is a graphite made of carbon. The positive electrode is normally a metal oxide of some sort. And then the electrolyte, which used to be the sulfuric acid, is a lithium salt. And that lithium salt is in an organic solvent. Lithium reacts very wildly with water. So you can't use anything with a watery type base, so it has to be a solvent of some type. But it's the lithium salt that creates the electrolyte in which these two, the graphite and the metal oxide as the anode and cathode, is basically running in. And this is an example of the of a typical lithium battery before they close it up. You can see it's a roll of 2 plates with the lithium in between. It gets rolled up and then encapsulated into a cell. And once it's encapsulated into a cell, you end up with a battery that basically is almost like a AA battery, a little bit bigger. And the size of the lithium battery is just so that they can get that rolled up, tightly packed away into this, and there you have a lithium battery. Now, this lithium battery, again, like with the lead acid battery, has a very small voltage, 2.3, 2.4, whatever voltage it is. So again, you have to have 6 of them, like in a torch. 6 of them together will give you your 12 volts, and that's a 12 volt battery. But that's not a lot of storage capacity, so you take 6 of them together and you put multiples of them together. You solder it all together and you pack it in a black box, and that is the Blue Nova lithium battery. It's a series of these small lithium ion batteries that is inside there, and then you have to manage it, because let's say you're sitting with 1,000 or 500 or whatever of these batteries, and then the system will then require a small computer chip that runs these little cells to make sure that they are balanced correctly, that they are monitored correctly. So all you have is basically a bunch of flashlights bonked into a black box with 2 outlets, and the lithium technology in there is exactly that. Lithium technology is very old, but it was developed to start using in cell phones and laptop computers, where you really need a small light battery with a big punch. And that is where lithium found its origins. With that all said, enough of the chemistry. I think it's time to go back and have a look at our upside down battery. It might have exploded by now, who knows. Let's go and have a look. Okay, looks like everything is still working. Cool. Still an upside down battery. Light is still running. No explosions. I'm still around, so it must be good. Now, to run this battery needs a few adjustments. So the first thing that you are going to have to do is, if you have an old grey box, it works. I still use this one, but I do not use the charging port. You cannot link your engine directly to a lithium battery, because the lithium demands so much power that it will just break your alternator. So how do you do that? You just put something in between to monitor and regulate the power that goes to the battery. To do that, you have a DC-DC charger, you have a solar charger controller, or you use a 220 volt lithium ion charger. That's it. So it's really on the input side that you have to make a few adjustments. On the output side, you can put the battery in here, you can still use your cigarette lighter, your grey plug, everything is normal. There's no difference on the output side. It is on the input side that you have to make a few adjustments. So with all that said, light burning, battery upside down, no explosions, no scary stuff. I'm still alive, so there's another video coming. All good. I hope you enjoyed this video. And if you have any questions, let me know. Otherwise, see you on the next one, because I survived this one. Cheers.